All right, now I want to pay more attention because I kind of skipped over stuff. We're doing Gleam. We are doing functions where we left off in the last video, and the fn keyword is used to define new functions. Um, the double and multiply functions are defined without the pub keyword. So here we have double and multiply functions that don't have pub in front of it. So these are private, only other things in this file can use it. So if another module tried to use it, it would be an error. Like with assignments, type annotations are optional for function arguments and return values. It is considered good practice. So which means, I guess I can just remove this double A and it still works. So we're trying to double 10. And you see that it still says 20 on the bottom, even though I got rid of this. Can I get rid of this also? Yep. So I can just write functions that look like this. Now we're like doing JavaScript, right? And I guess that works. And if I try to call double on a character or a string, it says I expected integer, but I got a string. That's because it did type inference and said double uses multiply, and in multiply, a is an integer. So a here has to be an integer. Now if I got rid of, here, let's comment this out. What was the comment thing? Was it this? Crap. Yeah, it was this, right? So now if we get rid of this, here, it still works. But let's see if it catches the error. What does it say when I do this? Expected integer. I guess because we're doing multiplication and it's saying, because of this multiplication, a has to be an integer. So that's how it inferred it. So that's pretty cool. But it does help a lot to make this, because now you just can like make a lot more sense. If we try to make these floating point numbers, let's see what happens. You see, if I do this and do this now, which is the floating point operator, now it said I expected a float, but I got an integer. So let's pass in a floating point number. Let's also get rid of this. Now, it's fine with our A because we're passing in a 10.0, but it's not happy with our B because this is, so let's just say, hey, look, this should be a float. Now it's unhappy here because it's like, hey, right, because remember when we gave it a type annotation here, it's unhappy because it saw this type annotation and said, hey, B should be in here. I know that you're telling me this is an integer, but it has to be a float, so it's complaining here. But once I get rid of this, now this is not the first error it sees. It sees an error here where it's like, hey, the 2 you're giving me has to be a float because of this, of the star plus. So let's change this to a float. Sorry, that probably hurt. Now what does it say? Type mismatch. A star dot B. This type of the return value doesn't match the return type annotation. So we said it's going to return an integer, but it returns a float, right? But if I just get rid of this altogether, now it should be happy, right? Because it's nothing in here is contradictory. And the funny thing is when it prints, it actually prints it without the dot, so you can't tell that it's a float, but we can make this a little more clear by putting a dot 1 or something. And now you see that. So if we wanted to fix that, we say, hey, this is actually a float. And then we say, hey, this is like, we can stop here, right? But we can say this is a float, and this is a float, and this is a float, and we return a float. And if we want to return a string, then probably we have something like, I'm just guessing here that there is a Gleam float and that we can do float.toString and pass this in because we were able to do it with integer. What's going on here? The type of this doesn't return. Expected type float found string. Are we just confused because of this? Float to string. This should be a float and it should return it as a string, no? So we're multiplying it together and we say this is a float. In the double function, right. Okay. Got it. Still, I should be able to do float dot to string val. Right. So now the double function is having the problem because over here we're saying this returns a float, but it's returning a string. Double float string multiply should return a string. Where are we running into a problem? There we go. Now it works fine. So the problem we were having before was this multiply is actually being called by double. It used to say it was returning a float, and it got confused here in this multiply saying, hey, this is returning, I thought I would be returning a float, but in fact I'm returning a string, which makes sense. I just didn't look at the line number. If this was an editor, it'd be a lot easier to use because just like in here, you see that there's line numbers, you would be able to like find it a lot better. Yeah, so the other thing that we could have done was just get rid of this, right? Because then it figures it out for itself. Thank you, how do I say it? Mau? Okay. Higher order functions. In Gleam, functions are values. They can be assigned to variables, passed to other functions, and anything else you can do with values. Here the function add1 is being passed as an argument to the twice function. We already did this. So twice is the charm, right? So do you think we can do this now? I'll just get rid of this again. Wait, this is, what do Gleam files end in? Like, what's the naming notation for a Gleam file? .gleam? What's the extension? Tell me. Oh my god, come on. vars.gleam, so I'm guessing it's Gleam. Source vars.gleam. Okay, so we'll just delete this. And we will write test.gleam. And maybe we'll get some syntax highlighting here. And let's see. So what we're trying to do here, we're trying to make a function that adds 1, which takes in a number and returns a number because it's adding 1 to it. We have curly braces, right? And then we just do I plus 1. This will actually return it. And then we have a function called twice, which I think is the public function that other people can use. That just applies a function twice to the initial value. So it takes the initial value, which is an integer, and then I think it's a comma, and then we have a function. We call it like apply function, and we give it its type over here, which is takes an integer and returns an integer. This does not look right. I think it's like parameters are in parentheses and the return type is like this. So this is saying it's a function that takes in one parameter that's an integer and returns an integer. If it had more stuff, it could be like this, but you know, we don't. So why is this not matching with the first parentheses here? What am I doing wrong? I probably have an error here. Ah. I think that's it. So this should close the twice thing, and it's saying that twice actually returns an integer. Well, let me just go on and we'll figure out what's happening. Now we can apply the function twice, and we pass it the initial value I, and then we have something that actually runs it, pub main. Are you guys seeing this? Yeah. Okay, Liquid, probably gonna sleep pretty soon, but really glad I got to catch your stream. Hope you have a great rest of your day, and I look forward to stopping by again soon. Thank you, Liquid. Take care. And then we do io.debug. We can print out add 1. We'll give it some value like 10. I think that's what I used last time. And then let's see if this compiles. Test Gleam. Do you think we can just like run Gleam from here? Gleam. The joys of Nix. Please don't let me down. There we go. Maybe we can just do Nix test.gleam. Run the project shell test. Check. Export. Run the project shell. Start an Erlang shell test. Target runtime module. Maybe this is not how you do it. Damn it! I was hoping we could like learn how to do this. But so far we know how to paste it into the Gleam page here. Syntax error. Pub main, I was not expecting this. Pub function main. Let's just fix it directly. All right. I was not expecting this. Plug function. So the syntax, I don't have the syntax right. I think it is, it takes in apply function, which is a parameter, and this is a lambda function. There we go. Function int that returns int. That makes more sense, right? Unknown module IO. And there we go. So it's able to call add1. And then, so yeah, I guess the syntax highlighting was correct. It was confused. That's why it didn't work right. If we were to fix this here, this would be apply function colon here. And now, yeah, now it's matching the first parentheses. So that's good. All right, now we can also do, yeah, thanks, Mao. No function before apply. Thanks. Where was I? io.debug, we will also call twice. And twice takes in a starting value and takes in a function like add it, an apply function. So we can do add1. And there it goes. It adds 2. It called add1 twice to the initial parameter 100, so we got 102. Yeah, I'm sure we're gonna get there, right? So these were higher order functions. I think the only other thing they did was they had a let, so they can do like let my function equal add1. I think you can do something like this. And then you just do like my function, and that still works. And then I can pass my function here. That still works. I think we have mastered the higher order functions. All right, now we have something else going on, as well as module level named functions. Gleam has anonymous function literals with the function brace, squiggly brace syntax. Anonymous functions can be used interchangeably with named functions. Anonymous functions can reference variables that were in scope when they were defined, making them closures. Right. It just means that within any of these anonymous functions, we can reference stuff outside of it. So here you have an example where secret is an anonymous function, but it's actually accessing secret number even though it's not being passed in here, right? Closures, it's very useful, but it's also a little scary because it's a little, you have to be careful. I'm not going to write this. Well, let me write like my example of it because why not, right? Does this work? I think I just have to do import io slash gleam, no, gleam slash io. And then we'll use this in here to a totally contrived example. My secret 1000. We keep getting bigger. So now add1 is always adding 1001. And let us try putting that in here. Syntax error. Let my secret. Oh, it needs to be in a function. Where do I have an anonymous function? Let's add one anonymous function here. No, that shouldn't be here, right? Sorry, I want to we call twice from here, so we can make it in here. io.debug twice, add one, and we'll pass in one. So let's just make sure this works first. Okay, so you see 3 here. We don't need this top one here. And now instead of add one being a function that we've defined over here, we're going to define the function here as an anonymous function. We can even just pass it in here, right? So we do function. Do we just put the I in here? This is good that I'm testing this because I don't really remember how to, the syntax is, I've forgotten already. So add one is I plus one. Is this how you make an anonymous function? I guess we can look. Function blah blah blah. I guess so, right? Let's try this. Oops. Yay, okay, no. This private function is never used. Yeah, so that doesn't matter because we can get rid of this. Or maybe we can even use this. Maybe this is good enough for it. Okay, it doesn't like it when you do that with a function. Okay, so this works now, no complaints. We have a lambda function in here. So now we want to test that, like, is this really a closure? We make a variable called extra sauce, and we make it 10. And then we're just going to add, the function that we're passing is going to add the extra sauce. Right? And it's not being passed in, so this will show that it's a closure. And now we see 23 because it's adding 11 each time we call it. So it's adding 11 plus the initial number, which is 1, which gives us 23. With the main function somewhere in the source files, why are lambda parameters not typed? Oh, here? Let's see if we can just do that. That worked. And that worked. No, didn't like this. Where would this go? This closes this. This closes twice. So it can't be in here. It needs to be like right after here. Maybe it goes in here, right? Like, yeah, it probably goes here. There we go. Now you see that it is typed. And if we change this and we say apply function here, this function I'm giving you is going to return a string. It should give us an error because my function is not returning a string. It's saying, yeah. So you can make it typed. Good question, though. Very good question. It does make your lambda function. Usually when you have like an anonymous function, you want it to be short, right? Because it's almost like you're too lazy to type a whole function for it. So I guess a lot of times you don't make it typed is my guess, and that you depend on the type inference to tell you whether it makes sense or not. Function captures. How far along are we? Oof. Generic functions, pipelines, labeled arguments, documentation comments, and deprecations. All right, now we're at function captures. Gleam has a shorthand syntax for creating anonymous functions that can take one argument and immediately call another function with that argument, the function capture syntax. This is the one we were at before. I was like, what is this? The anonymous function that takes in a parameter a and calls the function some function, where parameter a is the second parameter, can be written as some function comma underscore comma with any number of other arguments passed directly to the inner function. The underscore is a placeholder for the argument equivalent to a in function a. So does this only work if you have only one parameter, I guess? If you have an a, b, you don't like an underscore in two places, right? Because it wouldn't know which one's first. So let's see this in use. What's going on? The two statements are equivalent. So here we have function that takes in, do you guys see this? Yeah. Function that takes in a parameter x and it adds, it calls add 1 comma x. And then we have another version of the function that is called just add 1 comma underscore. Aha, aha, aha. This makes it's a shorthand for writing all of this. Alright, so Elixir does have something like this, but this is even less. But Elixir has a way to capture multiple parameters. I wonder, but yeah, one's very useful. So let us write this ourselves just to make sure we know how this works, because every time I think I understand it, I try to write it and I realize I have no idea what's going on. Okay, so I mean, on my screen, I'm not looking at it, but when I'm showing this, it looks like I'm looking at it. So I'll actually like go to the content so it seems a little more realistic. All right, so what are we doing here? I think we want an add function because that's kind of like the function we're testing with. Function add, and it takes in two parameters that are integers, and it returns an integer. So we do a plus b, and we're golden here. And then we want two versions of a I think add one. So we do a pub function main where we're going to try this out. And is that what it was doing? Adding one? I don't remember even, like, you see now I don't remember what the function was trying to do. This is like the short-term memory as hell. Anyway, so we have our function, like a lambda function, right? Add version 1 equals, here is a lambda function. I remember it was like taking an x, and then inside of it, it was probably just doing like add x comma 1. I think it was doing this. And then we can do io.debug add v1. And we pass in some number like 10. Maybe this is not at all what it was doing. Alright, so let's see if does this look right? At least, is this, whether it does what we want it to do, is this syntactically correct? I think so. Right? So let's try putting this into one of the things. We'll use it in another one because we don't want to see the answer. Okay, so this printed out 11, right? And now we're saying we can have a capture version of this where we just write add, and we're saying underscore is the parameter 1, and it's going to auto construct the anonymous function around it whenever it sees this. So then I should be able to call io.debug add version 2 10, and it should give me the same answer. There it is, 11. Let's see if that's actually what they did. Where was it? Was it here? No. Function captures. Here we go. Let's see. Is it similar? Function x add, yep, add 1. Oh, except that my 1 and the x were different places. So it just changed this, but it really doesn't matter. It means the same thing, and then they print both of them out, and they have add. Hey, I figured it out. We figured it out. Good job. All right, so we learned function captures. And now we're going to go to generic functions. This sounds really cool. All right, I got to take a quick break just for a minute. Go to the bathroom. All right, so where were we? We're at up to generic functions. This sounds pretty cool. Let's see what this is about. Up until now, each function has accepted precisely one type for each of its arguments. The twice function in the previous lesson on higher order functions. Oh, okay. Actually going to sleep now. Haha, keep wanting to keep watching. Good night, Liquid. Sleep well. You need sleep. You'll feel better tomorrow. And this will be a VOD later. So don't worry. You won't miss anything. All right. So let's see. Twice function in the previous lesson on higher order functions only worked with functions that would take and return ints. This is overly restrictive, and it should be possible to use this function with any type so long as the function and the initial value are compatible. To enable this, Gleam supports generics, also known as parametric polymorphism. This works by using a type variable instead of specifying a concrete type. It stands in for whatever specific type is being used when the function is called. These type variables are written with a lowercase name. The type variables are not like any type. They get replaced with a specific type each time the function is called. Try uncommenting twice 10, exclaim to see the compiler error from trying to use a type variable as an integer and a string at the same time. All right, let's see what's going on in this code. So we have a main that has add1, and it's and an anonymous function that adds 1, not surprising. And we have exclaim, which is also an anonymous function, and it adds, because remember this is an operator for concatenating strings. This will add the exclamation point at the end of the X string. Let's keep looking at the part that actually works. Twice 10 comma add 1. So this should be 12, right? And it gives you 12 here. Twice hello exclaim. So it's going to call exclaim twice on hello. Hey Jester, how are you? Oh wow, now chat's working again. How you doing? I'm doing well. We're doing Gleam. Doing Gleam makes me happy for some reason. I think just because like you go to the website and it's like already super happy. Look at that. It looks happy. Let's see. I think I was like clicking on some stuff. Was it under docs? No. Language tour? No. Sponsors? No. Community? God, there was something I was clicking on. It's like, God, this is such a happy site. Ah well, I can't find it. Cheat sheets, Discord code, language tour, playground, documentation, sponsors, roadmap. Yeah, I don't know where it was. But it was like, this guy was all like happy and animated. I was like, damn, this is really neat. All right. Where was I? Yeah, and we already learned, thanks, Jester. We already learned about making this twice function, which takes in a function as a parameter. So the problem here is that twice will fail on 10 and exclaim, because when it tries to do this, yeah, the expected type of function that takes in an integer and returns an integer, right? And that's because we're passing in 10. We're passing in 10. So that in order for this to work, we're passing in value 10, which should be an integer, right? Because that's the anonymous function here. But instead, we're getting a function that takes in a string, and it knows that just by looking at the this concatenation operator. CPP reference website. That's C++. Oh yeah. I mean, there's something to be said for this, but the Gleam website does seem happier in general, doesn't it? All right, I don't know what else to practice here other than, obviously, if we change this to like some string like this, then it's fine. And if we did IO debug on this, it added 2 exclamation points to it. So we didn't have to change anything here for this to work, right? To enable this generics, this works by using a type variable instead of specifying a concrete type. Where are we using a type variable though? argument vi. I guess this is a type. No. Yeah, I don't really know. We haven't changed twice at all, right? This twice is the same as the twice we had before. Let's go back in the contents. Was it in function captures? No. Twice? Nope, that's not it. Twice in anonymous functions. Oh! I'm just like really not paying any attention. They're actually passing the value as the type here. So this could be anything. Right, right. I wasn't parsing this right. So let's try to write this ourselves because I think it's kind of important that I didn't even realize what was going on, right? So let's try writing our twice function. Again, I know it's really boring, but this is how I learn, you know? Like I have to actually type it. So twice takes an initial value. Oh, even here it's not like a type. This is the old way. We'd have integer, and then we'd have the apply function, which is a function that took in an integer and returned an integer. And this whole thing, I guess we don't need to put in the type number in here. And we just called apply function twice. On the initial value. And then in here, we can just call let val equals twice. And we pass in an initial value like 7. And we'll call add 1 twice. We'll pass in this version of add 1, which uses, what is this called? Is it called like function matching, function blocking? Oh, function capture. It's right on my screen. Function captures. The function capture version. So we'll do add v2 here. And then we'll print it out, which is io.debug val. So this should get 7, 8, 9. This should return, it should print out the value 9. Here we will copy it, paste it over here, and it didn't like something. Initial, did you mean initial? I typed it in wrong. And it actually tried to help me. Here we go. It says you can ignore it, but look, it printed out 9, right? So yeah, let's ignore this guy here. No, not this guy, this guy. Because we're not using it. And now it has no errors. We're happy. It prints 9. There was this guy that I worked at a internet company. And there was this guy who was like CTO. Everyone would call him Pink Belt because he always wore a pink belt. He was not well loved. I hope he's not watching this. There's nothing wrong with him. He was just like, everything was always so fake, like whenever he spoke. So no one actually trusted him. But he'd always say like, oh, it's going well. The birds are singing. The birds are singing. Yes, the birds are singing. And it would just be this thing he said all the time. So whenever like something's working in my head, I go, okay, yeah, it works. The birds are singing. All right, so this worked, right? And now I wanted to make the generic version of this function. Yeah, pink belt. He literally had a pink belt that he wore, which I have nothing against. I love the pink belt. It's just like There was this guy who was basically as much of a robot as you can imagine, but also like never being real with the team. And yeah, so we just, what else to call him except Pink Belt? I actually don't remember his name anymore, so in my mind he's just Pink Belt. All right. So this compiled and printed out 9. Now we're going to try to make this version into a generic. So instead we pass in a type as a variable. This knows it's a type because it's coming right after the colon, right? So here's v, and if v is being passed as initial, then the function has to take in v also, and it has to return a v. That's how that sort of apply function would have to work, right? So now this should still work. Let's see. Hey, it worked. Now if I change this, yeah, now it fails. I make it v, it works again. This is a lot like Haskell where you just, put in like letters for what the type categories are. Damn, I'm tired a lot. I need black coffee. Seriously, I need coffee too, but I'm doing this and I don't want to make you guys wait while I make coffee. So maybe after these functions, I'll make coffee. All right, so now we need another version of add where of a function applicator where we're doing something else. They had an example where it takes in a string and adds an exclamation point. So let's do that also. Let me make a new one of this here just to test it first. So we'll call twice 7 and we'll pass it an anonymous function. That takes in a string. And then it does string, adds it adds a single exclamation point. And this should work, right? I think so. No, it didn't work. Twice. Operator expects, but this argument has type. Oh, because I passed in a 7. Whoops. um, big W. Yay, look, it added 2 exclamation points to the end because we called twice on this function that adds a single exclamation point, but since we called it with twice, it added 2. Big W. WW. Let's see. What do we have here, Jester? You should, because we can understand as this tried us a lot. So real. I feel so bad about it too. I'm so sorry I'm not better at this. I feel so bad for you guys. I'm learning TypeScript and advanced DSA. Okay. I don't really know TypeScript, but I assume it's a lot like this where we're adding like type notation to JavaScript, right? Pure script sounds really interesting. That should be on the list of things to play with. And advanced DSA, I don't even know what DSA is. What is DSA? Domain specific algorithms? Is this safe to Google? You promise? Digital Service Act? Data structures and algorithms. Is that what you mean? Yeah, that makes sense. I just never called it DSA. DSA learning. All right. I get it. So it's like, how to make trees, how to make red black trees, how to make graphs, how to traverse graphs, all those kind of things. Sounds good. All right, so where were we? Did we have a problem? No, we got it. We made it work. So now we want to show that we can do both at the same time. It's important for logical building and it will help you a lot in solving issues and bugs in optimized code. Yes, I totally agree. I spent some time learning data structures and algorithms, but I should review those and learn more. All right, so here we go. We did io.debug on this thing. This should still work, and now I should be able to clone this and just make this twice, like 7. Oops. And then I should just be able to pass in add v2. And now this will print 9, and this will print big W exclamation exclamation point. 9 big W exclamation exclamation point. Perfect. So we have succeeded in making generics, or at least reproducing what they did. Beautiful. Pipelines. I bet this one will be really easy. We're doing pipelines labeled. We can finish, guys. We can hang in there. The rest look easy. Super easy. I just need coffee so bad. Jester, are you making coffee? Are you almost alive? This is just water. I should have made like a big jug of coffee. Then it would have been better. All right, pipelines. Are any of you in a pipeline? Are you in the pipelines? I think I might be in a pipeline. But I think I'm in the end game. It's common to want to call a series of functions, passing the result of one to the next. Yeah, just like we did here. Remember where we did apply, apply? I hate this. It's super ugly, right? But we just want to say like, hey, whatever this is, take this result and call this other thing with it. In a CI/CD, continuous integration, continuous development pipeline, is that what you mean by CI/CD? With the regular function call syntax, this can be a little difficult to read as you have to read the code from the inside out. Gleam's pipe operator helps with this problem by allowing you to write code top to bottom. We're all kids inside. The sorry. Yeah, I don't really. Coding is like the mountain where you reach the top, but then you realize there's more to go. No, I don't really ever feel like top. I think it's fine to stay at the bottom of the mountain. This is bad. Where are we? Pay attention, focus, coffee comes later. The pipe operator takes the result of the expression on its left and passes it as an argument to the function on its right. It will first check to see if the left-hand value could be used as the first argument to the call. For example, A pipe B1, 2 would become B, where we put A as the first parameter, 1, 2. If not, it falls back to calling the result of the right-hand side as a function, i.e. B 1, 2 as parameters, and then A. So that means B 1, 2 will return a function, and then you can pass that function A. I assume that's what it means. All right. Gleam code is typically written with the subject of the function as the first argument to make it easier to pipe. So you always have to think when you order your parameters, like what's the thing that people are going to like want to pipe this with? And make that your first parameter. If you wish to pipe to a different position, then a function capture can be used to insert the argument to the desired position. Okay, there's a lot here. I guess we should try to look at it. Without the pipe operator, where we have to think inside out, right? So let's start from the inside out. Here's the most inside. String drop end hello Joe 1. And then we drop the start. So I'm guessing this drops the exclamation point, drop end, and how many characters you want to drop. So this is now hello Joe. And then we call drop start 7 characters, which is 1, 2, 3, 4, 5, 6, 7. It gets rid of the hello comma space. So now it's just Joe. So now you see Joe gets printed out first. But here it is with the piped version. We have hello Mike. We pipe this into string drop end, which it's going to basically try to pass this as the first parameter. So, and then it drops, and then whatever this returns gets put in as the first parameter to drop start, which is going to be hello Mike, right? Because we just dropped the end. And then we pipe this to IO debug, which prints it out, so it's just Mike. And we can see this, we can do this like over and over, kind of like hello foobar. It's just going to have foobar here, right? And here we're changing the position of the thing we're passing. So at first we're appending, this will append 2 to the first parameter. So it's basically 1, 2. So now it's 1, 2. And then we're putting the 3. We want the 3 to be in front. So now it'll be 3, 1, 2. And that's what we see here. So how does this work? This is equivalent. Remember, this thing is, I think we called it a function capture. Oh, it's like pop and push in Python. I think of pop as only one thing ever and push is one thing, but I guess Python, you can pass in a number. Yeah. Drop start. Anyway, let's I was saying that this is equivalent to writing a function that takes 2 variables, right? 2 variables coming in, because that's what append is. What? But it said only X. Right, so this is basically doing this. Function X. Now I've forgotten it. Hold on, we're getting there. Let's look at it again, damn it. That was function captures. Here we go. Yeah, function X add this thing. So whatever's on the outside, that's what it's calling. All right, so let's go back. This is, so it would basically be a lot like putting it in the front here. There we go. Right. Append 3x. There we go. 312. So this was the same as writing this, right? Because if you didn't do this by default, like obviously the 3, it would be like 1, 2, 3 instead, right? But this turns it into a lambda function that will call the function that you have here, which is append, and replace the input that it's getting. The underscore is the input into that position of the call parameters. So it's good to rewrite this every few times. You see, I forgot, I got confused, and now it makes more sense again. Yeah, the function chaining is exactly like Elixir, except with this, right? Elixir doesn't really have it. It has different captures where you use like $1, $2. So it's very, 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 very similar. I think that we understand this. We've written some stuff. We played around with it. And I guess we got this. Wait, was there something else here that they said? They said left side value, first argument. Oh, we did not try this out. So let's try to force our understanding a little bit more and understand what's going on here. So if it doesn't work, so let's give it a function that it won't work on, right? So for example, something that takes in, let's try to write something that takes in like, add exclam. We'll call it exclaim like they did it before. And it should take in the initial string. And it's going to add the exclamation point to it. So we'll write the version that actually works first. Function exclaim It takes in a string, which is a string. It takes the suffix or whatever, which is another string, and it returns a string. So here we just like add it to the end. And you can see here that we are now, it adds exclamation point to the end of 312. But let's say it didn't match this, then it's going to call B12, which would mean I can't call this, so I'm just going to call exclamation mark. Which can return a function, right? Because this B12 would be like just calling exclamation point. And it's going to take a string and it's going to return a string. I think this is how you would write it. Right? Okay. And now we just taken only one thing here. All right, we're getting, let's see now. So what are we trying to do? Let's return a function, which is append maybe we should return an anonymous function that takes in a string and it will return the string plus the exclamation point. Aha, look, it worked. Did it work? Did we work? Where is it? Where is it never used? 23 exclaim string, right. Do we understand what we even did? I think most of my programming is unconscious, so I don't even know what I'm doing. All right, so it tried to match exclaim. It couldn't, right? It couldn't figure out a string comma string version of it. So it just passes the thing in here. Here, it should pass this as a string. Ah, so we should use, this is going to be the suffix. Look at that. Now it's beautiful. So we can make this as question mark, and now you see it's a question mark. I just finished my website. Do you want to try? I can use ngrok to open for public for temporary. Maybe afterwards, Jester. Like this whole point of this video is to kind of learn Gleam, so I want to kind of get through it. I'm so sorry. But congratulations. Finishing a website is like important. I'm like a really bad web dev. So let's try to explain what happened here. It tried to chain exclaim, which is saying like it would add the string to this. So it's basically looking for an exclaim that takes in two strings. But as you can see, that does not exist. There's only an exclaim that takes one string, right? So then it defaults back to calling it without the return variable. You see there's no a here, whereas there is an a here, right? Which means it calls exclaim without this string. It just calls exclaim with this with the one with whatever input it's getting. You see it here. But now we're going to return a function. We're going to generate this function dynamically that takes in a string and returns a string. So it takes in basically it takes in a string and returns a string. So here's the string it takes in. And you see, like, that's this here, the A. So it's going to basically be the result of this. The function takes in the result of this. And we have access to suffix through the fact that this is a closure. So it can access the suffix here. And now we can still build this out. So I guess this kind of like shows this part here. But that was a little bit funky. I bet I would have a hard time remembering it again. Question mark, question mark. What do you mean? What's the question mark, question mark? Are you upset? All right, I thought all of these would be really fast, but it's taking longer because I actually tried them. But these are cool. I'm loving it. I'm loving it. No wonder people like Gleam. I'm thinking, like, if you saw this, it could be a little complicated. You're like, how did that work? But all right. Labeled arguments. When functions take several arguments, it can be difficult to remember what the arguments are and what order they are expected in. Oh yeah, this is like, doesn't Python do this where you can like change the order of the arguments? You just have to like call them something. To help with this, Gleam supports labeled arguments, where function arguments are given an external label in addition to their internal name. These labels are written before the argument name in the function definition. When labeled arguments are used, the order of the arguments does not matter. But all unlabeled arguments must come before labeled arguments. It's kind of interesting. It's kind of like keywords in Elixir, a keyword list where you have like these atoms. I mean, unless you know Elixir, but like it's kind of like you put those at the end of a function call all the time. So, and then they have names, they have labels almost, right? Because they are a tuple of like keyword value pairs. There is no performance cost to using labeled arguments. It does not allocate a dictionary or perform any other runtime work. That's great. Labels are optional when calling a function. It is up to the programmer to decide what is clearest in their code. Yeah, this really looks like keyword lists. Maybe it's really what it is on Beam. I'm not sure. But it does seem so similar that... Okay, so we have calculate. Let's look at the function. Value, int, add, end, int, multiply, multiplier, int. So this is the parameter name here, and this is the label name, I assume. And generally speaking, you don't want to use the same for both, I'm guessing. So that's why we call addend here and multiplier here and value here. Value is not a labeled argument, whereas addend and multiplier are. So here, when we call calculate, we pass in add and multiply in the order that it's laid out here. But here, we call it in a different order. It doesn't matter. And here we don't call any labels. It just depends on, it's just using it without labels. All right, so I guess the difference is that keywords are generally optional in Elixir. So let us try to just copy this without looking at it. I think the most key part here is the calculate function, right? So we have calculate, and it takes a value, which is like an integer, and then has an add label. Well, let's just do it the normal way. It's the addend, which is an integer. And what was the other one? Multiplier. And this returns an integer. So we basically have value plus addend, right? And we probably multiply by multiplier. That's my guess. And then here now we can just, if this is just a normal function, we can have a pub function main. Oops. And call calculate. We start with 1, we add the value 1, and we multiply 1. This should give us 2, right? io.debug. No, we've learned. We've learned pipelining. Does this look right? Oh, wait. I pressed the wrong thing. All right, let's put it here. Okay, it didn't like this. This parentheses cannot be understood here. I thought this is just like... I think we gotta use brace to make scopes. I typed it in wrong. Multiplier. I'm terrible. There we go. 2. That's what I said, right? All right. And 2 times 2 would make this 4. There we go. It's 4. Notice how it said error for a quick second there, huh? Isn't that interesting? Oh, it's just because it's doing this. All right. But now I want to write I guess like I want to write calculate 1 comma multiply, let's say 4, and add 3. So here it should give us, it adds 3, so it's a 4, and then multiplied by 4, it should be 16, right? This won't work because we don't have labeled arguments. Is that what it's called? Well, I think it's called that, something like that. Labeled parameters, labeled arguments. Unexpected labeled argument. I guess called a labeled argument. So now we're going to give it the name because it doesn't have multiply. So we'll give it multiply. Here we go. Multiply. And it's just a space from what I recall. Now it says I don't know add. So let's add add. There we go. And now it says 16. We're happy. The birds are... No one gets the joke. All right. So That was labeled arguments. Documentation comments. Where are we? We got 2 left. We got 2 left, boys. My ADHD time limit. I'm running up against it now. Oh my god, I'm so tired. I need my coffee so badly. Like, if I wasn't recording this, I'd probably just switch to something else now because my attention span is so bad. But let's finish. Documentation comments. You see, this helps me more than it helps you guys because I actually like get through stuff a lot better. So thank you. Even for the people not watching, thank you because it helps me that you exist even if you're not watching. How crazy is that? That's kind of like lazy evaluation. I don't even need to evaluate people not watching. Documentation comments. Documentation and comments are important tools for making your code easier to work with and understand. I object. Documentation takes time and no one reads it. I'm just kidding. Just kidding. As well as regular // comments, Gleam has // and // comments, which are used for attaching documentation to code. The 3 slashes is used for documenting types and functions and should be placed immediately before the type or function it is documenting. The 4 slashes is for documenting modules and should be placed at the top of the module. So here we have an example where this is a module documentation, and this is a type definition. A type where the value can never be constructed because it's recursive. And a function documentation, they're the same. For types and functions, it's the 3 slashes. And we don't have a regular comment, do we? I don't see one, but it'd probably go in here somewhere, like if this were my code, probably be something like that. All right, here we go. I don't think we need to practice that anymore in Elixir, by the way. There is like, I think it's like doc type, and then you have just a regular doc for functions, and then you have a doc module, I think, at the top level. But this is nice. It's kind of makes sense that this really separates out with 4 slashes. Then you kind of know. I like it. Do I like it better? Probably. Because you see it several lines. Yeah, Gleam is basically running off the same Erlang Beam virtual machine, at least as one of its options. So it basically is like Erlang with types. But I mean, it's more than that. But yeah, that's how I like so totally simplified in my mind. And strictly typing. I think I was gonna say more. Oh, I was gonna say that it also compiles into JavaScript so that you can use it in the front end. But the JavaScript runtime is a little bit different than the Beam runtime. So I think some things change, like floating point numbers are treated differently. Probably OTP, like concurrency, is different. I'm guessing. I'm not sure. But in general, a lot of the stuff just works on both platforms. All right. So we are looking at deprecations. And in fact, Gleam can call into Elixir and Gleam can call into Erlang pretty easily. Maybe that's in the content somewhere. Yeah, look at this. We want to use code written in other languages, external functions. So you can call in JavaScript external functions, but they don't show you how to do it with. The reason why it's only JavaScript here is because we're probably using the JavaScript runtime because we're in the browser. But if it were Beam, then you'd be able to call into other things, right? All right, this is the last topic of this video under functions. We've done all of basics. We've done all of functions now, and then we'll do flow control in some other session. God, I'm cold now. My hands are cold. I'm just falling apart. I probably need to eat lunch, so probably I'll stop after this. Maybe, Jester, if you're still here, we'll take a quick look at your website. All right, so let's see. Deprecations. Functions and other definitions can be marked as deprecated using the deprecated attribute. Look at this. It looks just like Elixir now. So that's cool. And it's called an attribute, just like deprecated. If a deprecated function is referenced, the compiler will emit a warning letting the programmer know they ought to update their code. And when I say just like Elixir, I don't mean that derogatorily. Like, I hope no one takes that. I love Elixir. So to me, I just can't help but notice some similarities. The deprecation attribute takes a message and it will be displayed to the user in the warning. In the message, explain to the user the new approach or replacement function or direct them to documentation on how to upgrade. I think whoever's writing this documentation, I think you need a comma here. In the message, comma, explain to the user. Maybe this is all like stuff we can, it's committable and we can write pull requests for it. We'll look if we have time. So here's some functions. Old function, it says don't use this. Old function nil. Oh, here it is. I was looking for the deprecation. I didn't see it because it was like, it looked like it perfectly lined up here and I didn't see the thing. Here we go. Deprecated value used, old function, this value has been deprecated. So it says use new function instead. So it was deprecated with this message, use new function instead. So great. Should we try this? Deprecated, and I just think it takes in, no, it takes in a parentheses and a string. This is pretty bad code. You should avoid it. Right? And we're calling it twice, so let's see what happens. It says it twice. Deprecated value used. Calculate this value as deprecated. It was deprecated. This is pretty code. Whoops. I should have said bad code. You should avoid it. There we go. Okay, so we know deprecated. And guys, we're done. Now we're in flow control. So that will wrap up this Gleam session. This is our second big Gleam session. So we're almost Gleam experts. We're almost a Gleamer. We're gleaming, but we're not fully Gleamers yet. We got basics, functions. Now we got flow control, data, standard library, advanced features. So we're like 2 out of 3, 4, 5, 6. 2 out of 6. We're a third of the way there. So in Gleamers, we're just Glee. We're just Glees. But I'm excited. And then after we finish these, I guess the idea is maybe we do some exorcism. Maybe we do exorcism after data types, because then we'll have the basics and we can kind of go back and forth for the rest. Yeah, so if you're watching this not live but as a VOD and you enjoyed this, please do like and subscribe. There's a Discord server also in the description, so try to join that. I'm glad we are learning Gleam together. Let me know what you think of the language. Thank you.